Hello everyone, this is Dorota and Maria, and we will tell you today about refinery and the modification of scikit-learn model using open source packages. First of all, we will introduce ourselves, then we will say something about scikit-learn if someone doesn't know it, and we will tell you what Python packages we will be using. Then we will show you our code in the notebook. We will tell you also what next can you do with this knowledge you'll get today. And we will show you some useful links so you can do some reading. And then we'll answer all your questions, hopefully.
Okay, so hi everyone, I'm Dorota Lączak and I'm Python programmer at IBM, and I'm working together with Maria in Watson Machine Learning team. I am developing and testing mostly AutoAI components.
My name is Maria Oleszkiewicz and I am Python programmer with some years of experience in IBM Watson Machine Learning team. And also I have some experience with Scala. Regarding scikit-learn, as probably most of you know, it is open source tool which will support you in classification, regression, clustering, predictive analytics, and all kind of stuff you can do with your data. It can be used in your project when you do everything with your data, from preprocessing to some classifications. Also, there are plenty of examples of usage for scikit-learn, which are available on their website. So it is very useful to take a look and see what you can do with it or how you can do it. And what can be important for some of us, it can be commercially used because it has BSD license. Other tools and Python packages we'll be using today is IBM Watson Machine Learning Python package, which will be used in our example to download the training data we used during an experiment. Lala Python package, which will be used for visualizing of pipeline and doing modifications, and AutoAI Leaps Python package, which generally is a library which contains transformers used for creating the AutoAI pipelines. So let's go to our example. This is IBM Cloud, and I'm using here a free account. You can create the same kind of account by yourselves. Everything what I will be using here is free, and all the Python packages are open sources. Generally, what we are doing now is in our IBM Cloud account, in the created project, I will create experiment, which generally is a process of creating pipelines and evaluating how well they are doing with the data set we provided. So to do so, we need to add to project an experiment what we can do with on the upper right part of the screen with an button add to project. Then we need to choose AutoAI experiment. We need to put some information like what is the name of experiment. Rest of the fields should be automatically filled by the service. And as the pipelines needs information about your data set, what are the columns, how many columns, what type of the columns, what type of the prediction and such, you need to provide a data set which will be used for training the pipelines. What we are doing here, what we are using is credit risk dataset, which is containing the data from the banks about the customers and if the credit can be granted or not. Exactly, if is the risk in granting credit or not that the customer will return the credit. So we can take a look into our data here. And each row describes some customer. We can see here some example values and some distributions. And on the right part of the screen, if we scroll a little bit, there is a risk column, which basically is a prediction column with information about each customer, if there is risk of granting a credit or not. So returning to our screen, of course, this is not time series forecasting, so we're choosing no. And we need to choose our prediction column, which in this situation is column risk we was seeing before. Also, automatically it is chosen that the prediction type is binary classification, the positive class is no risk, and it will be optimized for accuracy and runtime. Generally, all settings should be done right now, but if we would like to, we can go into experiment settings, the black button on the bottom of the screen, and modify some of the settings as we wish. Like if we know that our dataset in the fact is multi-class classification, we can modify this what is the positive class, because this can be not always correctly chosen by the algorithm. Some optimized metrics. In the other tab, as you can see, we can change settings of dropping duplicate rows or training on subsampling, subsampled data. Or we can choose if our data is containing text column and what are the settings around the text column we had there. If we need to exclude some columns, like columns with ID or some columns with unimportant data or data which shouldn't be in the training set, we can do it here. Yeah. And if everything is okay and all settings we have here are correctly set, you can run the experiment. Experiment is starting and we can monitor its status on the right. As you can see right now, the status is pending. And what it is doing right now, it is creating some pipelines, training on the data and evaluating how well they are doing. And when the pipelines evaluation and preparation is done, we can see them on the bottom part of the screen, where is a list, a ranking of the pipelines. So right now the training is done, and we can see here that the best pipeline is pipeline 4, which was created for XGBoost classifier, and which has some hyper optimization here, optimization, hyperparameter optimization. And on the right side, there will appear when you will hover over the element of the list, there will appear a button to save the pipeline. And you can save it as a model or as a notebook. The model can be later used for deployment and scoring, while the notebook is a pipeline with some additional code which allows you for some manipulation with it, like some refinery, some seeing what is the data, and such. So in our situation, we are choosing notebook. And about this part, will tell you Dorota.
Yeah, so let me share my screen with the notebook. Yeah, sure. And Maria, can you see my screen?
Yes, I can see it.
Okay, so let's go to our notebook. The notebook was prepared by us based on the pipeline notebook, which was generated based on our AutoAI experiment. And the notebook contains few sections. First, we'll start with the setup. Then we'll look more deeply in our pipeline in pipeline inspection section. And then we'll play with Lala and try to refinery our model. Okay, so let's start. First, we need to install some important packages that will be used in this example. And here in the next cell, we have some metadata of the experiment that was set during the AutoAI experiment setup, which was shown before. As you can see, we still have the prediction column, risk, and the accuracy, and also positive label is no risk. Here we need to load our training data, and we'll use them to model training and then testing it and checking the accuracy. To load the data, we are using Pandas data frame, and here we are splitting them to train and test set. Okay, now let's go to the next part where when we are importing all the necessary transformers and class and methods that will be used in model recreation step. As you can see, most of the imports are from AutoAI Libs package. It contains a lot of transformers and other estimators used by AutoAI, but as we'll see in the next cell, where all the transformers and classes are initialized with parameters that were chosen during the experiment. At the end, we have logistic regression. It is very common estimator from scikit-learn package. And here we need to connect all the steps to make pipeline. Now we have scikit-learn pipeline, but we need to train the model. To do that, we need to initialize our scorer, which is accuracy score from scikit-learn. And here we have pipeline feed on the training data. As you can see, the result of the cell is a pipeline with listed steps, which is not very clear for us. But Lala will help us with viewing and reviewing our pipeline models. Let's check and evaluate our model. It has accuracy 73.1%. And in next few steps, we'll try to create a better model. Accuracy 73%, it's not the best accuracy. It can be improved and we'll try to do it. To do that, we'll use Lala Package. Lala is open source package which provides semi-automated methods to evaluating, creating, and working with models. To start working with Lala, we need to convert the pipeline to Lala type. It's train pipeline type. Let's uncomment that. And as you can see, the accuracy of the model did not change at all. It is still the same model inside, but wrapped with some additional methods, such like visualize. The visualize method converts our pipeline steps to the graph, which you can see here. What is very helpful with the graph is the fact that each of the nodes contains a link to the documentation, and here we can read more about each step, what are the parameters of the steps. Okay, let's go back to our notebook. The second additional, very useful method from Lala to our pipeline is pretty print. It prints out the code, which can be simply copy and paste whatever in your Python project, to recreate the model. All the parameters were set, and at the end of this section we have making pipeline line. After running this code, all the pipeline needs to be trained. Also, the same code can be downloaded to script and used whatever you want. Okay. Now let's go to the refinery section. What will be done here is, at first we'll try to get better model. To do that, we will remove the last step of our model, which is estimator, and we'll try to choose the better estimator or better parameters for the estimator to get more accuracy model. To do that, at first we need to import the necessary estimators and wrap them with Lala function, which is wrap imported optimators. It wrap all the imported estimator. Thanks to that, they can be used by Lala later. Okay, so let's start with removing our last step of our model and freezing all the parameters for the, let's say, prefix pipeline. All the preprocessing steps here will be not changed in next experiments. What can be changed is the estimators at the end. By running this cell, we are adding possible choices at the end and defining search space for our optimizer. It can be done with few Lala specific signs. The doubled greater than sign means that we are adding something to the previous step, and the line means that we would like to logistic regression or decimal tree or extra tree estimators or KNN estimators or SVM estimator in our search space. Okay, if we have prepared some pipeline, we can start a HyperOpt experiment. As you can see, the experiment took around 4 minutes. We don't have much time to wait for that. And that's why before our presentation, I ran this code and we'll use the historical run of the HyperOpt. The HyperOpt is open source Bayesian optimizer that can be used in Lala. We simply need to pass the estimator which was prepared with our choices. We chose our max evaluation number to 9 and we pass the scoring method, and we would like to find the model which has the best accuracy. If you would like to play more with HyperOpt and experiment more, you can simply go to the documentation, and every of the parameters is described here. You can play with some cross-validation parameters, change the scoring methods, or set the best score you would like to receive, or set the maximum optimization of evaluation time of the experiment, and also additional parameters. Let's go back to our notebook. When the HyperOpt is done, we can list and see all the iteration of the HyperOpt. See what was the loss, how long it took, and the log loss value of the experiments. And finally, when the experiment is done, we can get the chosen pipeline and see what has changed in our model. Let's go to the end. And as we can see, the estimator did not change at all. It's still logistic regression, but with, as you can see, better quality on the same test data. So the HyperOpt changed the parameters of the logistic regression estimator, and thanks to that, we received a better, more accuracy model. Okay, let's go back to the presentation. To do that, we need to go here. If you are interested in our topic of our presentation, we can recommend you few more packages, open source packages. First is IF3060, also available via Lala. The package helps working with bias data, helps remove the bias from our data, and get our model more fair. And the second package, open source package, is ART. It's Adversarial Robustness Toolbox, which help evaluate, defend, and verify machine learning models, again, an adversarial threats of poisoning and many others. If you are interested, you can go to the documentation. There are many of examples of use them. You can also check some samples with Watson Machine Learning, play with our free account, test it. To test it, you can find the data sets on Kaggle, and I'm very interested and many data sets in this repository. And we hope you enjoyed our presentation, and see you in the Q&A section. Thanks.